Okay, welcome to Nomenclature. I want to say this is part 4, and this will cover covalent compounds. Let's move on. This is, remember, the outline that we are using from the Zumdahl textbook system, and he just comes up with these classifications called type 1, 2, 3, and 4, and they are just convenient ways to group the naming and formula writing rules, so there's some consistency in how you go about naming and formula writing. In the previous video presentation, we talked about type 2, ionic, with the variable cations and anions, and hydrates. So let's move on. Then we are going to go into today type 3 covalent compounds, which would be composed of nonmetals combining with other nonmetals. It is all covalent bonding, and they're all binary, although there are some very rare cases to where a nonmetal will bond with a polyatomic ion, and the nonmetal would be first, the polyatomic ion would be last, and it almost looks as if it's ionic, but it's covalent. We won't see any of those in this presentation, but that's a possibility, maybe on a homework assignment or on a website. The next presentation will be on the type 4 acids, and it will cover both types of acids. Then there would be one remaining part for the remainder of the chapter, which would cover chapter 7, section 3 and 4, and that would cover empirical formulas and molecular formulas, and also a skill called percent composition. Okay, we're not doing the student learning map, but here you go. And here's the next concept. Moving on to type 3. Type 3 are binary covalent compounds. Okay, looking at this, we have compounds that will begin with a nonmetal, and in all binary compounds where there are 2 elements only, the first nonmetal will be named with its full name. So we're not going to change the name. If it's nitrogen, we're going to call it nitrogen. We're not going to use the IDE ending on the first element. However, the second element will also be a nonmetal, and it will be named using the IDE suffix, as you would have memorized for that Set A quiz, I think, where you had to memorize the anions from the front of the ion sheet. How we will also name these is we will use prefixes to indicate how many atoms are present. Because they're covalently bonding, there are no charges to crisscross or re-crisscross in order to figure things out. And so we're going to use just a system of prefixes to talk about exactly how many of each element there are. So if you are going from the name to the formula, the first thing you want to do is you want to write the elements in order from the name. Then the subscript will simply come from the prefixes within the name. Never use oxidation numbers with these compounds. Do not crisscross anything with these compounds. And importantly, do not reduce anything to lower terms with these compounds. Literally what you see is what you get on these compounds. Okay, what prefixes will we use? Because this becomes very important. While there are prefixes that go well beyond 10 in this system, we're only going to stick with the first 10. Had you been in class, had we been in school, these would be memorized: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca, 1 through 10. These are also the very same prefixes used with hydrates in the previous presentation. So it's nice that there's a lot of consistency there as well. Okay, moving on. Let's check these examples out. So here we have carbon monoxide, or we drop one of the O's, carbon monoxide. This is a compound that you're familiar with. You've heard this before. And so, these things are in many cases common. So you have reference examples if you think about it. Here's another one, dinitrogen pentoxide. It would be pentaoxide, but we drop the A and just write pentoxide. If you put the A in, it's well okay. Dichlorine monosulfide, triphosphorus hexafluoride. Now, before we move on to the formulas, notice in all cases the first element that is written down has its full name. There is no modification to the name other than a prefix. And you may say, well, why isn't there a prefix on carbon? Well, in this compound, there is only one carbon, so technically it would be monocarbon monoxide. But chemists, for whatever reason, have decided that the first element will not use the prefix mono. All other prefixes it would have to have if there is more than one atom. But you do not have to use mono. But they did say that for all elements on the second elements, that will have their name modified with the IDE ending, we have to use the prefix mono or any other prefix. So the second thing will always have a prefix. The first thing will always have a prefix, except in the case where mono would be the initial prefix. So carbon monoxide. Okay, when we look down here, I5F7, CO2, Br3, Cl3, notice they're binary, and notice they all begin with nonmetals. Okay, all begin with nonmetals. And this compound here, CO2, should be very familiar to you from various science classes and anything that you understand about the environment, certainly. Carbon dioxide is part of that. Okay, well, let's go through some of the naming and formula writing, which I believe formula writing comes first. So here we go. Okay, looking at the name carbon monoxide, well, no prefix. So with no prefix on the first element, this means that there can only be one atom, so I just wrote a C down. For monoxide, mono is a prefix that means one, so there is only one atom of oxide or oxygen, so CO. Carbon monoxide, that's its formula, CO. Very deadly gas. It is a byproduct of incomplete combustion in many cases. It can also be the byproduct of other chemical reactions that produce it. Very deadly gas. It'll combine with your lungs 200 times more readily than oxygen will. So if you breathe in carbon monoxide and oxygen, the carbon monoxide will bond to your lungs, to the hemoglobin in your, coursing through what are they? The alveoli, I think, in your lungs well before the oxygen has a chance to bond. So very deadly gas. Here we have dinitrogen pentoxide. The prefix di means two, so there are two atoms of nitrogen, so N2. Penta is 5. There are 5 atoms of oxide or oxygen, so O5. Notice, no crisscrossing, no charges, no reducing, no anything. It's just literally what you see is what you get. I love these. They are so simple to do once you get the hang of them. Here we have dichlorine monosulfide. Di means 2 atoms, so Cl2. Monosulfide is 1 atom, so there's S, so Cl2S. And then lastly over here we have triphosphorus hexafluoride. Well, tri is 3, hexa is 6, so 3 atoms of phosphorus here, P3, 6 atoms of fluorine or fluoride, F6. Notice, do not reduce. Do not reduce this. I know the 3 and the 6 could offer that, but don't do it. The reason why is if you reduce this, and it would reduce to PF2 if you reduce this. If you did, then try and rename it. If you do, you would end up with phosphorus difluoride, and that is not this compound. And there's no way from that name you would ever think to produce this compound because there are no charges to check to say, oh, the fluorine is wrong, and so you have to multiply by some number. There's just nothing there because these are all, remember, covalently bonding. They're sharing their valence electrons. And as a result, it's just about the number of atoms that are needed to complete their octets, along with, as they share. Okay, let's move on. Okay, here is going from a formula to a name. So, what do we have? I5. 5 is a prefix penta. 7 is hepta. Remember, the first element gets its full name, so pentaiodine. If you want to drop the double vowel combination, then you could say pentaiodide. I'd drop the A, keep the I for iodine, and say pentaiodine or pentaiodine. All right? Full name of the first element. Second element gets the IDE ending every time. So that's consistent with type 1 and 2 as well. Heptafluoride. So pentaiodine, heptafluoride would be the entire name. Of course, we already know carbon dioxide, very common substance. And here is the set of names, or rather the set of formulas and the set of names that I typed up as an answer key before I did any of the handwriting to include something to discuss actually a little bit more stepwise than just flashing the correct answers. This would be something in class that we would actually have worked out on the board together. I would have done one or two, and then you would work on a few at your seats and compare answers to each other. Unfortunately, we do not have that experience, but at least we had this a little bit of interactivity as far as me to you, so it's kind of one direction, but you can certainly reach out to me if you want. And I believe this is the last slide for this particular presentation. It does, however, go here just to indicate to me that we are now transitioning from the type 3s into the next section, which will be the acids, and that will pick up with a new presentation. Thank you.